Hello friends. Welcome back to my channel. Today I'm starting new video series which focus on UK engineering knowledge, motor, past papers with answers. In this video series, I include the questions and answers covering the main topics and problems which are helpful for exams. So I invite you to stay tuned with this video series and keep subscribed for upcoming videos. In today's video, we are going to cover the questions related to air compressors. Let's see the video. Let's see the question 1. Part A. Explain why multi-stage air compressors are used to produce the pressure required. Part B. Explain why compressor lubricating oil consumption should be closely monitored and recorded. Part C. Explain why compressor inlet air filters should be maintained in a clean condition. Part D. Write a set of instructions that may be used to check the lubricating oil level in all the starting air compressor sumps. Okay, now let's see the answers for question 1. For Part A, to reach high pressures, as used for engine starting, at the required delivery rate, if a single-stage compressor was used, it would have to be very large with a small bump clearance and consequently would require a powerful motor to drive it. A further complication would be that as air is compressed it increases in temperature, polytropic compression. The temperatures reached compressing the air in a single stage would vaporize the oil film, leading to excessive wear and the possibility of a compressor explosion. In reality, single-stage compressors are used for low-pressure, 7-bar applications. By compressing the air in stages, the physical size of the compressor is reduced, allowing a smaller motor to drive it. The air can also be cooled between stages, again reducing the power requirement of the motor, see diagram, aiding moisture and oil removal, and reducing the temperature of the air in the final stage. For Part B, if the oil used to lubricate the cylinder liners in a compressor is excessive, then the oil will be carried over with the air. Oil carry-over in compressors is undesirable. It causes fouling of the compressor valves, interfering with flow and leading to sticking and leaking valves. It also fouls inter- and aftercoolers, reducing heat transfer, and in the case of intercoolers, reducing the efficiency of the compressor and leading to high second-stage temperatures. Oil carried over tends to oxidize due to the high temperatures and presence of oxygen. Oxidized oil is acidic and will cause corrosion in the air receiver and pipelines unless removed. Oil in air start systems is highly dangerous as it helps propagate an air start explosion. Oil in control air systems will cause blockages and sticking. For Part C, the volumetric efficiency of the compressor is defined as volume of air drawn in is over swept volume of cylinder. If the suction filter is allowed to get blocked, the volumetric efficiency of the compressor will be reduced. Less air will be delivered, less air drawn in, and therefore overheating will occur leading to excessive wear. In a direct reversing engine, the start air compressors may not be able to deliver sufficient air to meet the number of starts required. For Part D, with air receivers full and while maneuvering is not taking place. Isolate compressor electrically. Unscrew dipstick, withdraw and wipe clean. Dip for level of oil. Top up as required. Replace dipstick ensuring it is screwed in tightly. Switch compressor back on. Repeat for next machine. Let's move to the question 2. Part A. Describe the relief device fitted to an air compressor after cooler, explaining why it is fitted. Part B. Use a pressure volume diagram for the first stage of the compressor to explain the effect of bumping clearance. Part C. Describe the effect of a leaking first-stage discharge valve on a compressor's operation. Let's check the answers for question 2. For Part A, the aftercooler will be fitted with either a bursting disc or a relief valve of the type shown in the diagram. A simple spring-loaded valve, its purpose is to prevent overpressure of the cooler's cast iron shell casing in the event of a tube failure pressurizing the water side. For Part B, with a small amount of bump clearance, the small volume of compressed air remaining above the piston in the clearance space is quickly expanded to just below atmospheric pressure to allow the suction valve to open and air is drawn into the cylinder for a large proportion of the full stroke. With a large bump clearance, A considerable movement of the piston on its downward stroke is required to expand the trapped air to the point at which the suction valve opens. This leads to a loss in the volumetric efficiency. 4. Part C. Effect of a leaking first-stage discharge valve on a compressor's operation are: the air pressure after the first stage will drop. The volumetric efficiency will drop as the air leaks back into the first stage as the piston moves downwards, preventing fresh air being drawn in. The temperature of the air will rise as it is recompressed. The compressor running hours will increase, and it is possible that the cutout pressure will not be reached. Let's move to the question 3. Part A. Sketch a section through a starting air compressor showing the fluid flow paths and labeling the main parts. Part B. Explain why automatic drain traps are fitted at air compressor coolers. Part C. Explain why it is necessary to remove oil and water from the air leaving the starting air compressor. Let's see the answers. For Part A, the figure shows a double-stage air compressor. For Part B, when air is pressurized, the dew point temperature of the air rises. When the air is cooled, the water condenses and collects in the cooler. By fitting automatic drains, the water is prevented from building up in the cooler and then passing over with the air into the next stage of the compressor, where it would wash off the lube oil film or damage the valves. For Part C, if oil and water is not removed from the air before it leaves the compressor, it will cause corrosion and pitting in the air receiver. Additionally, the oil will coat the internal surfaces of the pipes, interfering with the airflow. A very real danger exists if the oil then carries over with the air into the air start system, where if it is ignited during an air start sequence, an air start explosion can occur. Let's see the question number 4. Part A. With reference to air compressors, describe, with the aid of a sketch, a two-stage air compressor suitable for the provision of starting air. Part B. State 3 factors which could be responsible for excessive operation of automatically controlled air compressors. Part C. Describe, with reasons, the problems which might be associated with air compressor high-pressure discharge valves. Let's check the answers. For Part A, the sketch shows a tandem-type two-stage compressor. The compressor casing is cast iron with a water-cooled jacket. The forged medium carbon steel crankshaft runs in white metal journal bearings. The aluminum low-pressure piston and cast iron high-pressure piston are fitted with cast iron piston rings and run in cast iron cylinder liners. The clearance between the piston crown and the cast iron cylinder head is minimal to keep the volumetric efficiency to a maximum. The suction and discharge valves are low-inertia spring-loaded light stainless steel plates. Relief valves are fitted after low-pressure and high-pressure stages, and bursting discs or relief valves fitted to the water side of the inter and after coolers. A high-temperature cutout is fitted to the high-pressure discharge. The compressor is started off load to reduce the starting current. After compression in the first stage to about 7 bar, the air passes through an intercooler to reduce the temperature, which increases the density of the air, improving efficiency, removes water and prevents overheating in the high-pressure stage. Air is then compressed to 30 bar in the high-pressure stage before passing via the aftercooler to the receiver. Factors which could be responsible for excessive operation of automatically controlled air compressors are: leaking automatic drains on inter and after coolers, partially chocked air filter, leaking discharge valves. Answer for Part C. HP discharge valves operate at high temperatures. The high temperatures combined with the repeated opening and closing of the valve can cause fatigue, causing the thin valve plate to crack. A small amount of oil will be carried over with the air, which can deposit on the valve plate and seating, causing a buildup of carbon, interfering with the airflow and preventing the valve from closing properly, which in turn causes further overheating of the air as it is recompressed. Excessive oil carry over exacerbates the problem. Use of modern synthetic oils have lessened the problem of carbon buildup, but it is important that the valves are maintained correctly to ensure they seal properly, and that the plates are changed regularly as part of the planned maintenance program. Okay, let's see the question number 5. Part A. Sketch a section through a multi-stage starting air compressor showing the airflow, the cooling system, and the safety devices. Part B. Describe a starting air motor system used for starting a generator engine, explaining how it operates. Let's look at the answers. Answers for Part A we previously discussed in Question 3. So please look at Question 3 answers. For Part B, starting air motor systems are used for smaller engines and can be mounted in pairs if necessary to provide the torque to start engines of up to about 3,000 kilowatts. They can also be usefully employed on 4-cylinder 4-stroke engines, which then can be started from any position of rest. They consist of a rotary vane air motor which drives a pinion. When the auto valve is operated by either a remote electrical signal or by hand, air behind a piston engages the starter pinion with the flywheel ring gear. The movement of the piston uncovers a port allowing the air to operate a control valve which allows air to the vane motor, which then turns the engine. When firing speed is reached, the system vents and a return spring acting on the piston disengages the pinion from the ring gear and shuts of air to the starter motor. Let's look at the question 6. Part A. Explain why high-pressure air is compressed in stages. Part B. Explain why compressor cylinder lubrication should be kept to a minimum. Part C. Explain why air compressors are started and stopped off load, describing how this is achieved in an automatic compressor system. Part D. Explain why compressor suction filters must be kept clean. Answers for Part A, B, and D are previously discussed on Question 1. So please see the Question 1 answers. Let's look at the answers for Part C. Most air compressors are driven by an electric motor with a direct online start. With this type of motor, the starting current is between 5 and 8 times normal full load current, and the starting torque is low. This can lead to overheating of the windings. By starting the machine off load, the starting current is reduced. By taking the machine off load before stopping, a sudden braking effect caused by the piston coming up on compression is avoided, which can cause stressing of the crankshaft and coupling. Starting and stopping off load is achieved by an unloading mechanism which holds the suction valve open until the compressor is up to speed, or by opening solenoid drain valves on the compressor discharge and inter and after coolers. Let's move to the question number 7. Part A. Explain why the bumping clearance needs to be checked when overhauling an air compressor. Part B. Explain why bottom end bearing adjustment does not affect bumping clearance. Part C. Explain why in multi-stage, single crank compressors it is not sufficient to adjust the bumping clearance in one stage only. Let's check the answers. Part A. The bumping clearance is the name given to the clearance between the top of the piston and the cylinder head. For a compressor to be efficient, the bumping clearance must be kept as small as possible and is generally about 0.6 millimeters for a 2-stage starting air compressor. Because the clearance is so small, when an overhaul is carried out, it is important that it is checked using lead wire or plastigauge. Fitting new bearings, con rods, pistons, and cylinder head joints can all affect the bump clearance, which can be adjusted by fitting shims between the conrod palm and the bottom end bearing. If the clearance is too small, then there is a danger of the piston striking the head when running unloaded, and if too large, the compressor may well overheat as the same air is recompressed over and over. Part B. Adjustment of the bottom end bearing clearance by fitting shims will not affect the bumping clearance because the loaded part of the bearing is the top half because of the air pressure on top of the piston as the piston comes over TDC. This means that the effective distance between the piston crown and the top bearing surface remains constant. Only wear on this bearing surface will affect the bump clearance. Part C. The sketch illustrates a tandem compressor at TDC with exaggerated bump clearances. It cannot be assumed when setting the bump clearance for the LP piston by adjusting shim thickness under the connecting rod foot that the HP clearance will be correct. This must be adjusted by the use of shims where the HP piston is fitted to the LP piston. Let's move to the question number 8. Part A. State, with reasons, why compressor cylinder lubrication should be kept to a minimum that is compatible with an acceptable cylinder wear rate. Part B. Explain the effects of operating an air compressor with a leaking first-stage discharge valve. Part C. Explain how the starting air receivers may be recharged in the event of a blackout cutting off the main electrical supply and only the emergency generator is operating. Let's see the answers. Part A. If cylinder lubrication is not kept to a minimum, then the following problems may occur. Oil carried over with will deposit on the hot discharge valves, causing carbonizing, leading to poor flow across the valve, and failure of the valve to seat properly. Oil may vaporize in the high-pressure cylinder of the compressor if the air temperature gets too hot. Although safety high-temperature cutouts should be fitted, a compressor explosion could result. Oil carried over into the air receiver will oxidize, causing pitting corrosion. If this oil is not drained from the receiver, there is the likelihood that it will be carried over into the air start lines where it could supply the source of fuel for an air start line explosion. Part B. If the first stage discharge valve is leaking, by then previously compressed hot air will be drawn back into the low-pressure cylinder on the suction stroke. This will reduce the volumetric efficiency of the compressor as less new air is drawn in and will also lead to overheating in the first stage as the air is repeatedly recompressed. Overheating in the high-pressure stage will occur as less air will be drawn in on each suction stroke, meaning the discharge valve will open later. Because the volumetric efficiency of the compressor has been reduced, the compressor will take longer to pump the air receivers up to working pressure. This may have serious consequences in the case of a direct reversing engine during maneuvering when there may be a shortage of air if engine movements are frequent. Excessive running hours, combined with higher cylinder temperatures, leading to lubrication breakdown will mean excessive wear, reducing efficiency further and increased maintenance. Part C. The main compressors are not usually fed from the emergency switchboard, as the load would be too high. Instead, a small emergency compressor supplying a generator start air bottle, which is much smaller than the main air start reservoirs, is fitted. This small compressor may be fed from the emergency switchboard, or may be driven by a small hand-started single-cylinder diesel engine. Once the auxiliary air start bottle is filled from this emergency air compressor, then a main generator can be started, and once connected to the bus bars, the main compressor is started and used to pump up the main air receivers. Okay, let's look at the question number 9. Part A. State the considerations governing main air receiver capacity. Part B. Explain why the internal surfaces of air receivers are coated with clear copal varnish. Part C. Explain the importance of regular maintenance of air receiver drain valves. Let's move to the answers of question 9. Part A. At least 2 starting air receivers of about equal capacity are to be fitted, which may be used independently. The total capacity of air receivers is to be sufficient to provide, without their being replenished, not less than 12 consecutive starts alternating between a head and a stern of each main engine of the reversible type, and not less than 6 starts of each main non-reversible engines. 4 twin engine installations. Then each engine must be able to start the minimum number of times. In the case of multi-engine installations, then an agreement may be made with the classification society as to the total number of starts required. Part B. The internal surfaces of an air receiver are subject to pitting and corrosion caused by the water and oil carried over in the compressed air. If this becomes excessive, the strength of the air receiver is compromised and may necessitate expensive replacement. To prevent this happening, the internal surfaces are given a protective coating which may be derived from organic products or synthetic. The properties required are: 1. The coating is clear, so that the surface of the receiver can be inspected. 2. The coating is flexible, so that it can expand and contract with the receiver. 3. The coating has good adhesive properties so that it adheres to the surface of the receiver. 4. The coating is impervious to oil and water. Part C. Air receiver drain valves are often automatic in operation. They must operate reliably to ensure that water and oil are drained from the air receiver. If they become blocked, then the oil and water accumulating at the bottom of the receiver is likely to cause corrosion, and there is a chance that any accumulated oil could be carried over with the compressed air into the air start lines, where it poses an explosion risk. If the drain valve do not seat correctly after operation, then this will lead to excessive compressor running hours, with resulting increased maintenance and cost. So my friends, thanks for watching, and if you like this video, please like and share. Keep subscribed for upcoming videos. See you in next video.